Hello, everybody. I'd like to welcome you to our webinar for this month, and just thank everybody for showing up and being here and being a part of it, whether you're watching live or on our YouTube channel. Just so that you know, all these are put on our YouTube afterwards, so you can always go refer to it, or if you happen to miss one, you can go from there. But no other announcements at this time. I just wanted to say welcome and thank everybody and turn things over to Scott here.
Alrighty, everybody. Appreciate you taking a little bit of time today to join us. We're going to just do a quick little, probably about 25-30 minute, little just brief discussion on our technical tip of the month, which is we're going to talk about pay stations. We're going to talk about gates and queues, how to use them, how to set them up, how to wire them. A lot's going to be focused on the electrical wiring because that seems to be a point in which we could all kind of grow our skill sets a little bit, and some technical calls we take on that as well. So again, today we're going to just take about 25 to 30 minutes to go over our technical tip of the month. And then at the end, as normal, we'll take any questions you might ask, and then we'll finish up the webinar. And as Jay mentioned, this will be on the YouTube page as well. Alrighty. So today, again, like I said, we're going to be talking about the gates, queues, and pay stations. Now, they have some interesting points when it comes to them, so it's worth noting some different things here. So big thing's going to be the voltages. Voltages, inputs, outputs. Now, these are changing a lot from pay station to pay station, equipment to equipment. So pay station, gates, doors, many other of your auxiliary wash equipment, they have multiple inputs and outputs that use different voltages and different sources of those voltages. Those voltages can vary between DC and AC. Those voltages can vary all the way from 12 volts DC all the way to 220 volts single phase AC. Now, it's important to know, what does the manufacturer of the gate or the pay station need for their voltages for their different inputs and outputs. It's really important to know this because we send the wrong voltage and it can be quite damaging to electrical components. So as I noted there at the bottom, knowing this information can be the difference between keeping the magic smoke inside our electrical devices and letting it out. It's also too important to know on how a manufacturer or a piece of documentation relates to certain terminology. So what does hot mean? What's the difference between hot and DC positive? What's the difference between hot and neutral? What's the difference between positive and common, neutral and common, ground and neutral? Now, these are all sometimes utilized in the same way, but actually mean different things. So it's important to have a good understanding of what each of these different terminologies mean and the voltages you're going to be using when you hook up your pay stations and your gates. It's going to save you a lot of time during your install. It's going to get your customers up and running quicker, get those pay stations accepting cash, and get those car washes washing cars. Now, when it comes to pay station, wash package vent outputs, they are outputs on your pay station, but they turn into inputs on your car wash equipment, or in this case, a Petit. So a lot of the things we talk about are going to be useful in all car wash equipment, all kiosks, but a lot of times I'll refer to specifically what it is inside the pay station or inside the Petit. All Petit inputs are 24 DC positive. This voltage must be supplied by the same power supply the Petit uses for its internal inputs. So even if your component has its own 24 DC power supply, which is very common in gates and pay stations, we can't use that 24 DC power supply to send voltages for our wash packages. That must come from the Petit equipment because it's our input, it's our voltage that we need to see. Now, when it comes to pay station out of service and cycle signals, wash and use signals, these are inputs at the kiosk, but they're outputs from the Petit or other car wash equipment. Petit's output for these devices are sent as dry contacts, meaning when we send your control panels, we send the relays that are associated with these two outputs dry, meaning there's no voltage on them. You'll commonly see we send other relays with 24 AC or 110 volt AC. These might be for signage or different valves. They already come pre-landed with that voltage because we already know what that device uses. In the case of pay stations, we don't know what that voltage is. So we need to send those with no voltage in and then you have to land the correct voltage based on what the manufacturer of the device recommends, in this case, a pay station. Once that proper voltage is verified by the pay station manufacturer specifications, that source needs to be identified within the Petit control panel and then landed on the 11 terminal of the correct output relay. So if you've kind of used relays in the past, especially on the Petits, the left-hand side of our relays, that's the A1, A2, that's the coil. That's what actually actuates the double pull, double throw relay. On the right-hand side of those relays, you have three sets of terminals. So you have your normally open, your common, and your normally closed on the back, or in a line, they kind of step back. We're used to landing a lot of our things on the normally open. That's the 14 terminal. What happens is when you fire the coil, the relay closes that contact. It goes from its normally open idle state to its actuated state closed, and it connects the 11 terminal to the 14 terminal. So whatever voltage is landed on the 11 gets sent through the 14 when it's actuated. When the coil de-energizes, the common is now connected electrically to the normally closed side, which is the 12 terminal all the way in the back, and whatever voltage is on the 11 is going off the 12. This is commonly used for open and close signs. So you put 110 in the middle. When you actuate and put the car wash into service, it sends 110 out to the open sign of a sign. When you shut off that relay, it takes 110 out to the normally closed side, which is the closed side of the open sign. So it automatically switches that way. But our output relays are sent dry contacts. 16 and 17 are sent as dry contacts. So once you identify that voltage, you find that voltage in the control cabinet and you land it on the 11 terminal to properly energize that coil with the correct voltage when used. We do provide a pay station setup and install guide upon request, but for those of you that already have our equipment, there's a technical document folder on the desktop. Within there, you'll see an actual manual that goes over in more detail some of the different configurations and setups that we're going to talk about today. But that again is on that desktop of your HMI technical documents folder. And then there's a pay station and gate manual in there for you to reference as well. If you don't have these documents on your HMI desktop, give us a call at tech support. We can drop those in for you remotely. Petit panels all come with 3 major voltages for use, which are the common voltages for pay station: 24 DC, 24 volt AC, and 110 volt AC. Now we're talking specifically about those IO. We're going to go back to the Petit wash package input. So again, your pay station is usually going to have a set of VEN terminals. 1 through 8 is common, 1 through 6, 1 through 4. And then usually always on the end is another terminal that's labeled common. In this case, the pay station is using the word common to mean what we were talking about with that relay. So it is, when it decides to fire a wash package, it electronically connects the common terminal to wash package 1, wash package 2, wash package 3, so on and so forth. So as we talked about earlier, the Petits need to see that input come as a 24 volt positive. So we're going to take our 24 volt positive from the pay station, from the Petit control panel, take it out to the pay station and land on that VEN common terminal. That way, when the pay station actuates the common to 1, common to 2 electrical connection, we will be sending the correct voltage back to the Petit input. You're going to want to land your VEN signal 1 to input 1026, VEN signal 2, 1027, so on, all the way to VEN signal 8, which will be 1033. Petit control panels always have their inputs on the left-hand side and the output relays on the right-hand side. So you'll find those 1026 to 1023 as terminal blocks on the left-hand side. You'll also find our 24 DC positive is labeled over there, and we also denote it using orange terminals. So when you see orange terminals, that's 24 DC positive. When you see blue terminals, that's a denotation of 24 DC negative. Now, when we get to the Petit pay station outputs, we talked about those briefly, but now we're going to a little more detail. You have output 16, which is our wash in service. Some pay stations have the ability to have a separate set of contacts to tell the pay station when it's in service and when it's out of service. These are separate from output 17, or a set of contacts in the pay station that's wash in use or cycle signal in the Hamiltons. Now, going back to the wash and service, if your pay station has this, it's always best to utilize those contacts. And then that also can be used for that open and close sign. But again, our output 16, which is set as a dry contact, the kiosk will tell you what kind of voltage it wants to see for its input, because again, out of service, in service is an input to the pay station and output from Petit. So dry contacts, verify from the manufacturer of the kiosk what voltage, land that correct voltage on the 11 terminal. Then on your pay station, they're usually labeled hot and neutral or hot and common. The hot will go on the 14 terminal, the normally open side of that output 16 relay. And in the case of, let's say it's 24 volts AC, the common side will go to our 24 volt AC common terminals. If it was a 110 volt, it would go to 110 neutral. If it was a 24 DC, the common would, or the negative non-hot side would go to 24 DC negative. So it's very important. Hot's easy. Hot's always going to be positive or hot if you're in AC or DC, but that common can be, depending on what voltage is, it either a common or a neutral, depending on what you're working with. Output 17 is our cycle signal and wash and use signal. Now, cycle signal is what Hamilton calls it. Everybody else calls it a wash and use signal. Now, we can configure this in two different ways. So in the case of a Hamilton, they have active and passive. That's going to be high and low. Always high, pulse low, always low, pulse high. But almost every other pay station, Unitex, Dencars, DRBs, the whole kit and caboodle, they're all going to use where it's high while in use, low while not in use. So again, we can set those signals in our HMI to react accordingly. So for those of you that are familiar with the HMI, you're familiar with clicking on the top banner that says AccuView. That's going to open up a menu like you see here. If you move down, you see our settings here. We're going to go to the wash and use cycle signal down here at the bottom right. That's going to open up this next screen here that allows you to configure the Petit to talk to your pay station correctly. So again, when you're talking about a Hamilton, you're going to see Hamilton likes these settings up here. If your Hamilton is in active, you're going to want always high, pulse low. If your Hamilton is in passive, you're going to want always low, pulse high. These are again for the wash and use and cycle signals, output 17. All other pay stations, you would click this high while in use. And then you'll notice down here, you have this enable disable tab. Some of you that might have old Watch Select 2s will know that the Watch Select 2s have kind of two different ways to take them out of service. You can either have a dedicated out of service set of connections, or they have like a little bit of a Morse code kind of a thing. So if you're only using the cycle signal, as you see here, it'll do an off on there to get that Unitech to go out of service. So once you again identify what voltage needs to be used, and then what configuration the communication with that voltage needs for your pay station to react accordingly, go out of service when the machine's taken out of service, and also cycle those different signals to tell it when there's a car in the bay as well. Moving on to gates. Gates are very similar to pay stations, as in they have a lot of different inputs and outputs and different voltages going on. Gates, there's kind of two prevailing ways a gate can be controlled. In most cases, you're going to find most car wash equipment doesn't mess with the gate. That gate is controlled by your kiosk. In the case with the Petit, we build that gate control into the HMI and into the PLC. So this allows customers using older legacy equipment, older Hamiltons, Unitex, whatever it might be, that have no gate control built in to utilize a gate, but also sometimes a more simple way, because we had to use it with older legacy equipment, a more simple way to control a gate in the event that some of the more sophisticated gate controls with the kiosks fail. So when a Petit equipment is being utilized, we are always going to recommend that the Petit control the gate when a gate is being utilized. Petit currently distributes the Elka branded gate system, but we can interface with any gate system out there because they all work on basic analog I/O. Gates are extremely valuable when utilizing Petit's built-in queue management. So we're going to talk about at the end of the webinar the built-in queue management within the Petit HMI and PLC that allows those legacy pay stations to utilize a gate to utilize a queue for faster throughput. Much like pay stations, I said gates have multiple I/O utilizing multiple different power sources and voltage. So it's very important we always check with the gate manufacturer to verify those voltages and then take good care when hooking those voltages up within the Petit control cabinet. Open and close signals are gate inputs that turn into Petit outputs. So again, that's one of those situations where it starts as a Petit output and then becomes a gate input. Gate alarm and loop detection are gate outputs that turn into Petit inputs. So if the gate has an alarm fault relay or the loop detection relay, those get sent to us and become inputs for us. So as we talked about earlier, all Petit inputs are 24 DC. So anything that is going to turn into an input from us must also have an extra wire to carry our 24 DC positive. Outputs, in the case of gates, again, just like pay stations, are going to have different voltages. So we got to contact our manufacturers so that we make sure we're identifying those voltage correctly. As I mentioned before, Petit does provide gate setup and install guide upon request, as well as on the desktop of your HMIs in the technical documents folder. Again, those of you with Petits, if you do not see that documents folder on your HMI, reach out to technical support and we can remotely drop that on for you. Gate I/O, each gate will use different voltages for the open and close signals. In the case of the Elka gates that you're going to get if you purchase one through Petit, those are actually ground operated. For a lot of you guys that might be a little bit more in the controls, where a lot of things are source positive actuated, these are sync negatively actuated. Like PayStation, Petit supplies its gate open and close relays as dry contacts, so there will be no voltage landed on them. We will need to identify the voltage and land it on the 11 terminal. In the case of gate control, ground voltage will need to be brought from the gate to the Petit output relay's common terminal, the Petit 10 or 11 output, the 11 terminal on that output. Again, just like a Petit needs its voltage to come as an input, the gate will need its voltage to come as an input. So we'll bring the control voltage from the gate, land on the Petit relays, and then out back to the gate for the open and close signal. Gate loop detection of faults, as I said, will return as a Petit input. So a 24 DC Petit supplied voltage must be sent to the gate and returned through the appropriate contacts on the gate controller back to the associated Petit input. For example, 1034 is the Petit input for the loop detector. So if you have a gate, we're going to get that loop signal back into our input 1034. Now, the Petit queue management, I kind of talked about that a little bit. So the Petit, every Petit that's ever been sold has the ability to manage a built-in queue. We build that logic into the HMI. So this allows you to utilize, whether it's a kiosk, a button box, a guy on a computer hitting the button, whatever it is, you can stack up to 10 cars. We utilize this because the pay station doesn't know how quickly a wash happens. They all have a little bit of a minimum reset time, and that's usually 5 to 15 seconds. So what the Petit does is it takes the first wash, and depending on how many queue spots you set up, it takes the first wash, opens the gate, lets that car come, waits 15 seconds, and it tells the pay station that wash is done, give me another one. Now in reality, that car hasn't even made it to the door yet, but the pay station doesn't know that. It just said, I saw what I needed to see. It's time for me to give you another wash. Whether that car has already paid utilizing the pay station stacking function, or they just pulled up to a gate that's closed. So again, we would send that signal. The pay station says the wash is ready for another wash. It would send us a wash. We would open the gate. That car goes through, close the door. 15 seconds later, we ask for another wash again. We'll continue this cycle until the built-in queue set point is full. Then the pay station will act like your standard pay station, where one in the bay, one at the pay station paid stacked, and cycle through. As a spot opens in the queue, it will let the stacked held pay station wash through and continue to do that and manage the queue for you. Again, we can manage up to 10 vehicles. This allows operators with any kiosk and a gate and the lot space to accommodate it to have up to 12 paid customers on site ready to enter the bay at any time. The pay station is one of the biggest slowdown points for throughput, whether they're fumbling with their credit card payment, utilizing your selling screens that are on the screens at normal flow path, or trying to feed $1 bills into the cash receptacle. It is the slowest point of the wash that we don't have any control over. Having that pay station with a gate and that lot space, we can absorb that one slow customer with 3 or 4 customers who were quick with their payment and are now ready to enter a bay. This would be 1 washing in the bay, again, 10 on the gate, and 1 at the paid kiosk waiting for the gate to open. This is how we get to that 29 cars per hour, is by having that car waiting at the door, already paid, waiting for the green light to come on and enter the bay. Again, this can work with any pay station or even a button box. I've had some service stations where they're like city garages. They don't have a traditional kiosk, they just have a button box. Anything that fires that signal, we would able to reset and take another one until the queue is full, and then the lights will control it at that point. Now, how to set this up is, again, clicking on that top menu would bring you to this open setup menu. We'd click our queue length button here, which would open this next screen. And then you'd be able to set the queue amount of cars beyond the pay station and the gate right here. So if you don't have a gate in queue, this would be 0, 1 car past the gate 1, so on and so forth, up to 10 cars past the gate. Now, if you are utilizing the queue management, then you would may or may not be familiar with this screen. So if you click in these white boxes area in the home screen, it's going to open up the queue management screen. From here, you're going to be able to see all your cars in queue. You can modify those cars, you can delete cars, you can add cars, you can clear the queue. There's some management that can be done from this screen with the cars that are already in queue. Maybe someone jumped out of the line and now you have an extra one that you need to get rid of, but then how do you know? Do you get rid of the $20 one, the $18 one, the $16 one? Which one do you get rid of? Commonly, on those very rare occasions, you get rid of one car, you bump everybody up to the top end wash and run them through, and then everything cycles itself out. But again, clicking from the home screen on the white boxes will open up the queue management screen. And from here, you have some options to utilize the queue with cars already in it, adding cars to it, or changing the washes for the cars that are in it. Something we wanted to add to all of our webinars at the end of the webinar before we start taking questions is our technical support contact information. There's a lot of resources out there, fellow operators, your ASPs, your authorized service providers, but ultimately we do think we are one of the better resources out there. So we do encourage us to be one of your first calls with any issues with a Petit. So I always like to take this opportunity to give that information. 330-861-0760. Option 2 is going to get you to our technical support team. Also can send emails to our technical support team at techsupport@PetitAutoWash.com. We talk about the normal business hours as well as our emergency technical support hours, which I'll leave this screen up for you. And then for your customers, as we're getting, we're on all 50 states and on 5 continents now with the Petit team. So for special circumstances and international support, we can arrange those for outside our normal business hours, whether you're in the Australian continent, in Southeast Asia, Europe, or South America. We're going to be able to help you out with those times. Sometimes those just need to be set up ahead of time to make sure we're available for those situations. At this time, we've kind of finished our tech tip for the month, which was our gates, pay stations, and queues. Hopefully, we were able to take a little bit of knowledge away from that. We do like to take this opportunity each month when we do these things to open up our time for questions, whether that's in the chat or by raising your hand. At that time, I'll take your question and hopefully I'll be able to give you a little bit of information to help your solution. So I'll be quiet now and let anybody raise their hand or type in the chat if you have any questions. Again, while we wait for anybody who may or may not have any questions, I just want to remind we have our technical support contact information up on the screen. Pettit Technical Support is going to be your number one call for any issues you might have. Your ASP is also going to be a great local expert. They're going to be the ones who have seen your site and have the intimate knowledge of your site. But if for some reason they're not available or you need that extra help, PetitAutoWash Technical Support is going to be a great call for you. Again, we have that information up on the screen. If anybody needs that, we'll leave it up for a little bit longer. Sometimes no news is good news, so I'm not seeing any questions, but we are always here if you do have questions later, so don't hesitate to reach out to the technical support contact information we have on the screen. If we don't have any questions, I think we're going to go ahead and close the webinar out for today. Hope everybody has a great weekend, and we'll see you at the show.